We have the Block 1 Revision B Higher Maths, New Higher Maths, CFE Higher Maths, and these are what the sub-skills that the questions relate to. So Block 1, as we do at Wade Academy, is straight line differentiation, sets and functions, including transformations of graphs, trigonometric functions, and things like f of g, g of f, and inverse functions, and also recurrence relations. Different schools might do it a different way, but if you are being assessed on these assessment standards, this is good practice for you. Let's have a look at the questions. A straight line has the equation 2x plus 3y plus 6 equals 0. Find the equation of the line parallel to the given line which passes through 4, negative 6. We need the gradient of this line. We need to rearrange into the form y equals mx plus c. So we make 3y the subject. We then make y the subject. And the gradient is negative 2/3. We know, or we should know, that for perpendicular gradients, the product of perpendicular gradients comes to negative 1. So the gradient of the perpendicular line will be 3/2. Again, we have the point here, 4, negative 6. So we just substitute into y minus b equals m bracket x minus a. So the mark is given for this line. There is absolutely no harm at all in expanding this and making it into a suitable form. You will need to do it in the final exam because there will be some sort of simultaneous equation question related to a straight line, no doubt. So multiply absolutely everything by 2, so we get 2 bracket y plus 6 equals 3 bracket x minus 4. Multiply out the brackets, plug the terms onto the right hand side. A similar question here. We have a kite. We need to know that the diagonals of a kite bisect each other at right angles. So if we don't know that, I've just told you. You've done that in second year. You may have forgotten. So the gradient of RQ is 3. So the perpendicular gradient will be negative 1/3 for the same reason as given there. Substitute into the y minus b equals mx minus a. And then your mark is given for this line. Actually, I've put that in the wrong place. There we go. Then cross multiply the 3 or multiply every term by 3. Tidy up into a suitable format. We could have written 3y plus x equals 2 there to make all terms positive. That would have looked more mathematically elegant. Calculate the size of the angle between the lines y equals 4x plus 3 and the y-axis. When we do m equals tan theta, we find the angle between the x-axis and the line. So if I extended the line down here, this angle, where I've put the dotted line in, would be the same as this angle here between the x-axis and the line. So as a gradients 4 is equal to tan theta. So theta will be tan to the negative 1 of 4, inverse tangent of 4, which is 76 degrees. Now that's this angle. The question asks for the angle between the line and the y-axis. That's why it's a hashtag mark. So it's actually asking for that angle. So it is testing your understanding rather than your ability to aimlessly substitute into a formula and find the inverse tangent of a number. You do have to have some sort of reasonable degree of understanding there. Health and safety regulations say that the gradient wheelchair arms should be less than 0.1 for safe use. So do tan 165, or I know this angle is going to be 15 degrees, so I've just found the tangent or the tan of 15 degrees, which is 0.27. Remember, m equals tan theta, so the gradient of that line is 0.27, which is too high for safe use. If it's any higher than 0.1, it is not safe. Make the statement. You must make the statement. That's what this little hashtag mark here is for, making the statement, interpreting your answer in the context of the question. The diagram shows the graph of y equals f of x. Here's the 2 turning points, so I've marked those on. How does this transform the graph? F of x plus 3 moves the graph, every point on the graph 3 to the left. The plus 2 on the end moves every point on the graph 2 up. So literally you're taking your maximum and minimum here, moving them 3 to the left and 2 up. So I've marked those points on before drawing, then I've sketched the same shape. It's got to be the same shape. Put your X and your Y on as well. Number 6, a tricky question. Before I go into what I've done here, let's have a chat about log graphs. The graph of y equals log to the base a of x goes through the point 1, 0 and a comma 1. Now we should know that is expected knowledge, I suppose. The log graph is the inverse of the y equals a to the x graph. So if you're wondering what a log is, it is the inverse function of y equals a to the x. So if we wanted to solve 5 to the power x equals 20, 5 to the power something equals 20, we could solve it using logs. We do that in Unit 3. We go into that properly in Unit 3, or Block 3. In Block 1, we are just interested with the fact that the inverse of a function, if we look at it graphically, is just that function reflected in the line y equals x. So we should know this. If we reflect that, we get the inverse of y equals a to the x, which is y equals log to the base a of x. So always goes through 1, 0. It also always goes through point a comma 1. So for example, if the graph goes through 8 comma 0, sorry, 8 comma 1, then I know that the base has to be 8, because this graph always goes through a comma 1. So if it's going through 8 comma 1, the value of a has to be 8. So we'd write that as this as y equals log to the base 8 of x. So if it was going through the point 12, 1, it'll be y equals log to the base 12 of x. If it was going through the point 2, 1, it'll be y equals log to the base 2 of x. Let's go and have a look at the question. So we need to understand that to answer this question properly. So just to confuse matters, I've called this base A, and the question is being called base B. But it's basically the base we're talking about. We could call it X, Y, well, probably not call it X. We call it C, D, E, F, G, H, I, call it whichever letter we want to. So we have a log graph that's also been shifted along by 3. So in a similar way that this was shifted to the left 3, this graph has been shifted to the right 3. I can tell it's been shifted to the right 3 because I know that a log graph should be going through 1, 0. This goes through 4, 0. So it's been moved 3 to the right. So in red, I've drawn on where just the graph of log to the base b of x would be without this transformation of moving 3 to the right. And also the point 8 comma 1 would also have to move 3 to the left, so it would become 5 comma 1. So we've gone 3 to the right, let's move to the right 3, so a is 3, again because the graph's been shifted, 3 to the right. Now the base, I know it's going through 5 comma 1, so going back down to what was said here, it always goes through a comma 1. So as it's going through 5 comma 1, that means the base must be 5. So a value of b is 5. If you're not quite getting what I've said there, make sure you talk to your teacher before it. Even if I'm your teacher, come and see me about it. Or if you're obviously in a different class, go and talk to your teacher about it. Or in a different school, obviously talk to your teacher about it. Next question, sketch the graph of y equals 2 cos bracket x plus pi by 4. Another horizontal transformation here. We're moving pi by 4 to the left because it's x plus pi by 4. That moves the cosine graph pi by 4 to the left. The 2 at the front stretches the graph vertically. So I've already drawn it in. I'll talk through the process I went through. The cosine graph, as we should hopefully know, looks something like this. Let's see how well I can draw it. It should be a little bit lower there, but never mind. So it starts at 0, 1. It's moved pi by 4 to the left, or 45 degrees to the left if we're thinking in radians. So rather than starting at 0, 1, it's going to start at negative 45 or negative pi by 4, comma 1. It normally crosses at 90, but it's been moved to the left 45, so it should cross at 45. It normally has a minimum turning point at 180 degrees, or pi radians, if we're talking in radians. So it'll move at 45 degrees to the left, that'll be 135. This point of intersection here is normally at 270 degrees, but it's moved to the left 45, so it'll be 225 degrees. The peak normally occurs again at 360, or the maximum turning point, I should say. That moves 45 degrees to the left, so that will occur at 315 degrees. Now I need to turn my radians, I need to turn those degrees that I just mentioned into radians. So 45, this point here, is just pi by 4. 135 degrees, well, if we count up in 45s, 45, 90, 135, so that's 3 lots of pi by 4. It's 3 times as large as that. 3 times as large as pi by 4 is 3 pi by 4. 225, again, count up from 135. 135 add 45 is 180, add 45 again is 225. 225 degrees is 5 times as big as 45 degrees, 5 times as big as pi by 4. It's 5 pi by 4 radians. And similar idea here, 7 pi by 4, 315 degrees, for exactly the same reason. We should also mark on 2 pi because we are being asked in the question 0 to 2 pi. Note this point and this point are at the same height. Well, they should be slightly out. Okay, because the wave has a period of 360 degrees, so this height here and this height here should be equal. So we have a sine graph that has been transformed. The overall height of the graph is 4 times as large as it normally is. So it's been stretched by a factor of 4. Let's have a look at what the sine graph looks like. It's always worth doing a quick sketch on these questions. It's also upside down, so it's also been flipped vertically, so it'll be negative 4 rather than just 4. So it's 4 times as high, and it's also been flipped upside down, so it's negative 4. Here we have one complete wave in 720 degrees, so it's been stretched. Now horizontally, if we put a number in here, that compresses it. So if it's half the size, it's been compressed by a factor of 1/2. Or if you like, it's been stretched by a factor of 2. Again, if it's a number greater than 1, that represents a compression. So to stretch it by a factor of 2, we just need to put in a half. Or going back to our National 5 terminology, there's half a wave in 360 degrees. So it'll be sin a half x. And also the center line. So if we drew a line through the middle of the sine graph is normally 0. Here it's 4, so it's been moved up by 4. So C is 4. Functions f and g defined on suitable domains are given by f of x and g of x. H of x is equal to g of f of x. Find an expression for h of x. So h is g of f of g, sorry. I've just got that bit the wrong way around. Slight mistake. Let's just change that. So that's g of f. So f of x is 4x minus 6. That becomes g of 4x minus 6. Substituting into g, so everything in the bracket is substituted in for this x here, so it becomes 4x minus 6 plus 2, which is 1 over 4x minus 4. Explain why x equals 1 cannot be a member of the domain of h of x. Well, we cannot divide by 0, so the denominator cannot be equal to 0. So 4x cannot be equal to 4, x cannot be equal to 1. So x equals 1, not in the domain, because we cannot divide by 0. Question number 10, find the inverse function of f of x. The method to do that, swap the x's and y's around. So x equals 2y minus 5. Rearrange to make 2y the subject, then rearrange to make y the subject. And by doing this method, you're finding the inverse function of the original function. You're finding the inverse of f of x. So the inverse of f of x is x plus 5 over 2. Let's just have a look and just check to see that that is indeed correct. So here, f of x says take x, double it, subtract 5. So to undo doubling and subtracting 5, we would, let's have a look at the inverse. We would add on 5, then we'd half it or divide it by 2. So that is indeed the inverse of doing this. So if you've done that, then you've done that, you'd be back to where you started from with any number. And that is the inverse. A recurrence relation question, you're giving the recurrence relation un plus 1 equals mun plus c. You're giving 3 terms. By using consecutive terms, we can generate 2 equations that both contain m and c. So here, substituting u3 and u2 into this original equation, so un plus 1 equals mun, that's the next term as m multiplied by the previous term. So u3 will be mu2 plus c, substitute in to get equation 1. u3 and u4 are also consecutive terms. Substitute those values in as well. Once we do that, we have a pair of simultaneous equations. Do equation 2, subtract equation 1. Note if we do equation 1, subtract equation 2, we'll get negative numbers. Not quite as nice. You want to avoid any silly mistakes. And the best way to do that is keep the numbers positive. So 11m subtract 2m is 9m. C subtract c is 0. 38 subtract 11 is 27. So m will be 3. Substitute in 2 3's plus c equals 11. So c is 5 because 2 3's are 6. Add 5 equals 11. Then we'll just state the actual recurrence relation here. Find the recurrence relation described by the sequence and use it to find the value of u7. Well, I know u4. So substitute in u4, I get u5. Substitute in u5, I get u6. Substitute in u6, I get u7. 1091. There it is. Question 12, another recurrence relation question. I will let you have a read through that yourself. But the remaining amount of litter each day, 80% is picked up, so there will be 20% left. So the next day, there'll be 20% of the previous day's litter, plus another 6 kilograms, which is dropped every day. So un plus 1 equals 0.2 un plus 6. Part B, immediately after the campaign, following an uplift of litter, the councillors believe that 3 kilograms of litter remains in the park. I'm assuming that's based on them actually going out and doing some sort of survey. Was the campaign successful? Well, let's find the limit. So the limit formula is b over 1 minus a. So that'll be 6 over 1 minus 0.2. So we've got a un plus b. So 6 over 0.8. 6 over 0.8 is 7.5 kilograms. So the limit will be 7.5 kilograms. But after the campaign, there's only 3 kilograms of litter. So this advertising campaign seems to have been a success. So based on the original information, we're expecting 7.5 kilograms per day. After the campaign, there's only 3 kilograms of litter per day. So 3 kilograms is less than 7.5 kilograms, the limit based on the original information. Therefore, that's 1 dot with 2 dots underneath. We can use that as therefore in maths. That's universally accepted. The campaign was successful. On to the differentiation questions. So find f dashed of x given f of x. The first thing we need to do before differentiating, we need to write the powers, sorry, the roots or the surds, or any power that is on the denominator in index form on the top of the fraction as a numerator. So root x is x to the half, so 12x to the half. Here the 1 and the 3 stay in the same place. If you like, we still have a 1 there because it just says x, that's 1x, same thing. Bring the x to the 4 up, that'll be x to the negative 4. Once in that format, we can differentiate. So half times 12 is 6, reduce the power by 1, negative 1 half. Multiply by the power, negative 4 times a third is negative 4 thirds. Reduce the power by 1, negative 5. So your marks are given for that. As we started in this format, we should really end up in that format. So x to the negative half is over root x. X to the negative 5 is over x to the power 5. The 6 and the 4 thirds do not move. It is only the x that moves with the power. The 4 thirds is not being raised to the power negative 5. It is only the x that's being raised to the power negative 5. The height in meters a golf ball t seconds after it's hit can be represented by this formula. The vertical velocity of the ball at time t is given by v equals dh dt. Find the vertical velocity of the ball after 4 seconds. So the velocity, as it says here, is given by dh dt. So let's differentiate h. We get 32 minus 8t. And after 4 seconds, substituting 4, the velocity is 0. Or the height is, oh, it's the vertical velocity, yeah. So the vertical velocity is 0, not the overall velocity. So as it's a golf ball, it'll still be moving sideways. It just won't be moving up or down at that point. Or the velocity will be 0 in the vertical direction. Explain your answers in terms of the movement of the ball. So when v equals 0, when the vertical velocity is 0, the ball is at the top of its flight, so it's rising, rising, rising. And the vertical velocity is 0, so it's only traveling sideways at this point here, then it drops down. So it stopped rising and it is about to start falling. So we'd say that's stationary. That's a stationary point of the curve. If we drew this curve, the stationary point would be at a value of 4. So that word stationary there is the important word. A curve has this equation, find the equation of the tangent to the curve at the point where x equals 1. So I've drawn a little diagram to explain this because this question came up a few times from pupils who required a bit of assistance. So I've drawn a curve that might look like this curve. I certainly know it's a quadratic. I certainly know it's positive because it's 6x squared. Find the equation of the tangent to the curve at the point where x equals 1. So tangent to a curve is a straight line which just touches a curve but does not cross it. As it's a straight line, I need 2 bits of information. I need the gradient and I need a point on the curve. Well, I know x is 1. I don't know the y coordinate, but I do know that this formula gives me the y coordinate. So substitute 1 into this formula and that gives us a value of 4, so the y coordinate's 4. So that'll be that point there. And then we also need the gradient. Of course, when we differentiate, we're finding the gradient. So dy dx will be 12x minus 3, and we're looking when x is 1. So the gradient at this point will be 12, 1 subtract 3, which will be 9. So now we have the gradient and a point on the curve. We just substitute into y minus b equals mx minus a. And again, get in the habit of rearranging that. But your final mark is given for that line. One more question. The cross-sectional area of an open rectangular gutter can be expressed by this formula. Find the value of x which maximizes the cross-sectional area. Important word. Maximize, minimize. It's an optimization question. We need to differentiate. That finds a rate of change. When the rate of change is 0, we're at a maximum or a minimum value. Okay. So we'll differentiate 60 minus 4x, make our statement, a dash of x equals 0 for a maximum value. So 60 minus 4x equals 0. 60 equals 4x, divide through by 4, x will be 15. Now we need to justify that that's a maximum. We can't just assume it's a maximum, we need to justify it. So we need to do that via a nature table as always. So we'll look at 15, we'll look before 15, and we'll look after 15. That is the only turning point, so we can pick any value that we want to. Okay. The natural thing to do would be to pick 14 and 16, but if we're being a little bit clever about it, we can make life slightly easier for ourselves. 0 is before 15. 60 minus 0 is 60, which is positive. After 15, we can pick any value. Let's pick 100. 60 minus 400 is definitely negative. Okay. Again, we could substitute 14 in and do 4 14s and get 56. 60 take 56 is still positive. As long as there's no other turning point, so here there's only one turning point or stationary point, so we can pick any value either side. And once we've done that, we must write our statement. So x equals 15 units maximizes the cross-sectional area. Should probably write off the gutter there.